have a pet theory that only bad projects get finished, because a bad project, right, you do it, doesn't really go anywhere. But a good project, if you build it and like it and you use it, it sparks more ideas. When you're using it, you see what's missing, you see what more you could have added. Something in your brain says, this is good, but it'd be even better if we added this or that, and off you go. Good projects have a life of their own. They have legs, and you're forced to run with them. And so it is with Marcin Kulik's 14-year-long project, Asciinema. It's a project that can record and play back anything from a quick demo of how to use the command line, to a live-streamed coding session, to an entire movie, provided that movie can be rendered in a monospace font. It's the Asciinema, hence the name, and it started life as a terminal transcript program and has grown to so much more. It's a great project. I've used it for screen recordings and demos in READMEs. It's really nice for that. But today we're going to look beneath the surface because it's a fascinating project to learn from. It covers data structures, rendering techniques, an astonishing number of languages. I think we cover Python, ClojureScript, Go, Rust, Elixir, and maybe some more. And it goes through a lesson that we all have to learn in the end. Don't write a parser with regular expressions. Let's get into it. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Marcin Kulik. Joining me today is Marcin Kulik. Marcin, how are you doing?
Great. How are you? Thanks.
Very well. Where are you coming in from in the world?
I'm currently based in Poland.
Poland. Okay.
Yes.
Okay, so we're roughly in the same time zone.
Indeed, yeah.
Roughly-ish, smearing it out.
Yep.
So you've been doing this project for, I think, 14 years, if my research tells me correctly.
Just about right, yeah.
And I think it's brilliant. There are lots of associations I have with even older projects, but we'll get into that. But maybe we should start with, you can tell us what Asciinema is.
Sure. So Asciinema, aka Asciinema, that's how I pronounce it,
Okay.
is a suite of tools for recording, sharing, streaming terminal sessions. It's something I started developing, as you said, 14 years ago, and it's been my passion project since then. And in a nutshell, it allows you to record your work in a terminal, but just by typing a command asciinema rec, which starts a new session that gets saved into a lightweight recording file. And then this recording file can then be replayed on a web using a custom-built Asciinema player. So you can embed this player on your own website, or you can use Asciinema's hosting platform known as Asciinema Server that you can self-host, or you can use the publicly available instance that I run, which is at asciinema.org.
And I've seen these all around the place. I mean, on the edge of my consciousness, I have seen Asciinema playing in lots of places where it's like, oh, this is a terminal demo of something that someone wants to explain to me. And I'd never really thought about the infrastructure that goes into making that work. Right, so maybe I first have to apologize for ignoring your work under the hood, but now we can make up for it.
Yeah.
So I often think with these things, when I'm trying to understand things like this, I start by thinking, what's my naive implementation? How would I try and build this? But you've been working on this for so long and you've rewritten it so many times. Maybe for a change, I'll ask you, what was your naive implementation? Where did you start?
Oh, okay. That's a fun story. So somewhere around 2010, 11, I was playing with this old school Unix command called script,
Yes.
which has a counterpart called script replay. There are two commands, script and script replay.
I didn't know that.
Right.
Yeah.
And so, on Linux, I think, that was at the time on Linux, you had script and script replay, where you could, the script command captured everything that was printed out to a terminal while you were working in it. And it was producing this lightweight text file with the whole content. And it also produced additional second file that contained a timing of like every event that was printed, that there was associated timing information, like what was the delay between this print and the next print and the next print. So
time
having
being
those
the
two
thing
pieces,
that prevents
timing,
you seeing everything at once, right?
Right, exactly. Yeah. So script replay takes those two files and replace that, and it felt like magic, like seeing like terminal just moves on its own, like doing those things, typing those commands. That felt really, 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 really cool back then, and I thought, okay, maybe I can record some tutorials using that and share these files with friends. And then I looked into how to what would be the easiest way for me to share this with people. The recording files created by the script command are called types. TypeScripts. TypeScript is a file, not to confuse with the new
hopefully no one's going to
language.
sue on that one. It's probably too late.
So those TypeScript files. So I thought, okay, I'm gonna send this over, email to a friend and ask him, okay, can you run this command script replay path? And that felt rather inconvenient if I want to just show someone, if people were already used to use sending a link to YouTube, right?
Yeah.
And I thought, okay, how can I make this simpler? So I thought, okay, I will maybe try to let me look into how to replay those files in a web browser. So I spent some time like analyzing the file structure. It was very simple, just mostly there are several flavors of those TypeScript files, but if you have this format where you have two separate files, the first one is just the raw binary data that was printed by a program, by a shell. Everything that program printed to standard out or standard error, then it was just appended to the file raw with no extra changes, like byte
Did it
by
not
byte.
capture standard in as well?
Not the. It can do in this extended format,
Okay.
but that came later. I think I don't remember. It can do that as well, but then you get additional file, or you need to use this extended format where the script command uses a single file with some structure where it labels different event types. Very similar to what Asciinema's ASCII-cast file format does. But back to the story. So I looked into that, and it felt like, okay, I have timing information, I have what to print, and I need to interpret this stream of data that was captured, and this is where the first challenge comes in, because you can't just like take everything and just start appending it to like some div on a page and just like incrementally add to it, because there are some control sequences that control colors, text colors, cursor movement, clearing of screen, all sorts of
things.
things.
When someone presses delete, then the appending
exactly
is ruined.
There's like the backspace character and all that stuff. So what I needed to do was to build some kind of rough terminal emulator that interprets the stream of data, builds a virtual buffer of characters, just like terminal has a grid of characters, and then render those resulting characters in some loop according to the timing. So the original version was very rough, and I didn't really implement like a proper control sequence parsing or like other like, it was very like hacky thing. I just glued together a bunch of regular expressions that I was like matching the text, like each frame or like each event that happens at an like that happens next. I was matching against a series of various regular expressions, and that was how I was making sense of it, and it kind of worked. It was very rough, and was falling on very trivial cases where you have anything much more complicated than just some simple typing in a shell. Then it was all falling apart. But it showed me that it can be done, and I thought, okay, this is cool. If I can make it, and the player somehow make it work reliably, and if I create a hosting platform for it, so people can just treat it as a terminal YouTube, they will be able to share those links to those recordings, and this will be the easiest way to share the recordings.
So at the time, I did that. Anyone who wanted to be a publisher was like using the Unix script command and uploading those files.
No.
Oh, okay.
So that was around that time. That was the very early stages. I thought that using script command just solves me the recording part, but I had a colleague who was I was using Linux back then, and I had a colleague who was using Mac, and I approached him and I told him, "Hey, I have this recording. Can you replay this on your machine?" I was curious, like how this will look like in macOS native terminal.
Yeah.
And he said, "Well, there's no command such script replay." And I was like, "What do you mean? You have script, but you don't have script replay?" And he said, "Yes." And it turned out that macOS didn't have script replay, and the script command didn't even record any timing information in the second file. It was only able to just capture the output with just like in full, but no additional information. So
sadly,
script replay made no sense.
I've never heard of that.
Right. Yeah. So now I believe these days it changed, and they upgraded script and script replay along those like 14 years. I don't remember when. But back then it was not there. Even though like the most of like Unixy tools on macOS comes from the BSD heritage. Yeah. And for example, on FreeBSD, it was always there. The script replay was there. So someone made a decision that it's not needed. Anyway, so I thought, okay, well, then here's the problem. Like, I need to create my own recorder, just get inspired by how script does it. So I opened the script.c file, read it. It's not that long, actually. It's a handful of screens. And I learned how it does it.
Straightforward, right?
Yeah. It's the main thing it uses is pseudo-terminal, PTY, which is a facility in Unix-like systems that allows you to pretty much like become man in the middle between your terminal and the programs running in it. So you can you're responsible for transferring input and output between terminal and your shell. And this is how, in fact, this is how Tmax works, how GNU Screen works, and even SSH uses PTY, pseudo-terminals. So it's all the same mechanism.
Makes perfect sense.
So I thought, okay, let me create my own Asciinema recorder for based on this script C file, and then I realized Python, which I wasn't really like a Python developer back then, but I knew it. I used it for some things. Python has a built-in PTY module in the standard library, and you can implement a very, very rough like capture of terminal session in Python in probably like not more than 20 lines, maybe even less, using this module. So I did that, and it worked, and it worked on Linux and on Mac OS. And I thought, okay, cool. So now I just need to save that into a file, and then I will be able to use that file with the web player. So that's the beginning, pretty much. Yeah.
Out of curiosity, did you, when you implemented the Python version, did you keep the same file format that Script was using?
Initially,
I'm
I think
asking you
so.
to remember details from like 12 years ago now.
I think so. Well, it was a long time ago, but in the very early stages, yes, I used the TypeScript. So it was like actually a set of two files. Yes, that was the case. And then later came the official Asciinema's own ASCII-cast file format.
Right. At some point, you must have broken away from regular expression parsing if you wanted to catch all the corner cases. So at what point does it get a genuine ANSI parser?
Yes. The tool was getting popular, and I was getting more and more issues from people that something renders wrong, and it was pretty much like a lack of proper terminal emulation and proper ANSI, like a proper stream parsing. So I thought, okay, I will never make it very reliable if I will not have a proper parser there and perform proper terminal emulation. And at the time, I was doing Clojure professionally.
Okay.
And I thought, okay, it could be a little fun project to just try, because you can also the player, the Asciinema player is a front-end thing, the JavaScript library. It was always like that. So I need something that works in the browser, and thankfully Clojure has a ClojureScript compiler that can compile Clojure code into JavaScript. And I thought, okay, Clojure is so much pleasure to work with, and dealing with data structures with in Clojure is a delight, and parsing and terminal emulation. This is pretty much all just data structures and algorithms. There's like you can like if you leave the input part, like a keyboard part, which Asciinema player doesn't handle at all because it just replaced what was only captured. So the player doesn't need to handle with input. Yeah.
Oh wait, is this because if I type the letter A, then you don't need to record that because the screen's about to repeat the A on the output to display it back to me?
Yes, exactly.
Yeah, of course.
So that's the system is doing the echo thing. So this is the echo mode of a terminal. which can be toggled with some syscalls, terminal control, tc, set, alter, etc. Anyway, by default, the echo is on, so whatever gets inputted gets outputted automatically. So I capture what gets outputted.
Yeah, that solves that mystery.
Programs like any program that asks for a password, and then when you type, it doesn't print that password. Those programs typically disable echo mode.
Makes sense.
And so the input goes in, no output goes anywhere. So this is why the player doesn't really need to deal with the keyboard, with keyboard layouts, all those things that are probably like projects on their own. Yeah, and if you also like ignore the rendering part and just stick to like parsing the stream of captured data and turning that into like a grid of virtual buffer of characters with their attributes like colors, bold, like text style, etc. This is just data structures. There's like no side effects, nothing. And Clojure felt like just a right fit for that, and that was my weapon of choice back then. I just enjoyed it.
You know what's really weird is you and I must have been developing in ClojureScript professionally at roughly the same point in the historical niche, because there weren't that many Clojure and ClojureScript programmers back then.
I think so. That was probably the golden age of ClojureScript.
Yeah, totally.
Yes. So that was around for me. Well, I started looking into this like implementation of proper parser and terminal emulator in Clojure. I don't know. It was 2014-15 probably. So I thought, okay, let me just try it. Let's see, like, if I can do that. And what was immensely helpful was there's a guy called Paul Williams who created a fantastic state diagram for like VT100 compatible terminals. Where there's just like a big SVG file with all those like states and transitions. Like basically, it shows you like what are the states the terminal is in, what are the different like modes, and which bytes by the particular specific byte values trigger which transitions. So terminal is people think like, okay, it's just like a grid of like just the text and then buffer, like a buffer, and then pretty much you know just print stuff. But terminal is like a complex state machine. It has like probably around 10 or something different modes that can be toggled with control sequences,
right?
That control everything. So if you toggle some various modes at random, the next print may just not be visible at all. You may try to print hello world and it goes nowhere because terminal is in some state that just like.
Give me some examples, because we've got echo on and echo off, I'm guessing, are two modes. I can't think of any others.
Right. So well, there are things like, you know, if you obvious things like when a control sequence is not properly terminated, then you start a control sequence for setting the text color to red, and at the end you need to put the character M to like execute this, like switch the foreground color for next print operation. If you forget to put that M and just start printing like hello world, then it will not it may keep reading those characters as a part of a control sequence, not as a text to print, for example. So that's one thing. Another thing, if you like, most programs terminate control sequences because they would not do their job very well. But for example, if you move the cursor to the right edge of the screen and you flip one of the modes, like I think there's insert mode, where instead of or hold on, insert, there's replace mode. There are many modes, but one of the modes, I think it could be the insert mode. Basically, you move the character to the right edge of the screen, turn on the insert mode, and you start. If you want to print hello, and normally in a normal mode, it would just like type H and move back to the next line and print hello.
Yeah.
But with the insert mode, it will just start like inserting every character of the word hello into this one single cell. So at the end, where the cursor was originally, it will stay there, and you will end up with a letter E in it. Sorry,
Right.
hello,
With
hello,
D.
O or D. If hello worked, then D. Yeah. So there are things like that. So it's not just like you take the text and you just like append it somewhere. You need to be aware of all of those different modes and how they interact with each other. So there are different things, also like scrolling regions. So programs like Vim use that, but not only Vim. Basically, program can say, hey, from the 5th row to the 20th row, I want this to be a scrolling region. And terminal remembers, okay, I remember that. And then next time, Vim says, okay, please scroll that scrolling region we talked about by 2 lines up. And the terminal does exactly that, just scrolls only that region, leaving the top and the bottom parts like intact, which is handy for Vim to like keep the status bar in place while you are scrolling inside of a buffer, for example.
Yeah. Is that also how it does things like split windows?
It's complicated. Like horizontal splits. Potentially that would be useful and used. For vertical splits, it gets more tricky because there is some also some very like minimal support for like the vertical like regions. So like
Okay.
typical scroll region is like that. And then but this is not really supported by a lot of terminals. So probably they do just some workaround or just some old school way of doing that.
Yeah. This makes your front end seem like it's got to be a lot more sophisticated than I thought, because your front end isn't just a player; it's actually a proper terminal emulator to some degree, right?
Yeah, exactly. That's the case. So I first when I started implementing that, I implemented this Clojure library called VTCLJ. Obviously, the name is
straightforward name
for Clojurists. It's obvious name, VTCLJ, and it was just this thing for parsing ANSI, sequences and having like a virtual representation of a screen buffer. And then I implemented like a front end UI thing that takes those characters from the grid and renders them with different color attributes, text styling, etc.
I'm curious. What's the implementation in the DOM? Because you could do it as a never-ending stream of divs, or you could do it as a table, or you could break out a canvas tag. What's the right way?
I'm still searching for the right way, actually. as we speak. Okay. Just yesterday, I was trying another approach. Well, one thing is that from the beginning, Asciinema's like value add was that you can actually pause the playback and select the text and copy paste it.
That seems useful. Yeah.
Yeah, because it's text after all, and we are not really like we have the source material, the whole text that was printed in terminal. We have that in the recording, so we can actually render that as a text that can be selected and copy pasted. So that was one of the priorities for me, to keep that, because people really enjoyed this aspect of it. So initially and up until recently, it was pretty much like a HTML pre-element with some child elements inside of it, with classes for text and background applied.
Mm.
And that was animated using a front-end library. At the time, there was a React style, but the a data-oriented one for Clojure. One was
I remember.
but I didn't
Yeah.
use that one. There was a different one, Rum or something. I don't remember. Anyway, yeah, that was used like pretty much DOM elements and applying classes.
Right. So the
mostly.
grid is kind of maintained in memory because you're rendering to a virtual grid and then sticking that in a pre-tag.
Yes. Yeah. Exactly. Yeah. So there's always like a source of truth in a memory buffer somewhere, and then that gets conveyed to the DOM. And I did some tricks like only updating lines that changed and nothing more. So like instead of redrawing, like updating everything. Those like React style libraries help with that because they can do the diffing, virtual DOM and stuff. So
I'm surprised you optimized that, because I wouldn't have thought the frame rate on replaying a terminal was high enough that you'd need to worry about the performance of it.
Oh yeah, so I didn't really worry about it for a long time. I still don't really worry about it because the like 99% of recordings are like chill, just typing some stuff and getting output from commands, maybe some code editing in Vim, etc. But this is not really high frame rate material.
Yeah.
But people started to, because the simple things worked very well and smooth, people started, doing more heavy things and recording some animations like C Matrix and like
that's the version
Cacophire.
That's the version of the film The Matrix that's done in ASCII.
Yes, exactly.
And you can play that back in Asciinema.
Yeah, of course.
Brilliant.
Yeah.
We won't talk about the copyright issues.
Yes. Yeah, we should probably. Okay. So people started recording various things. Even there was one person who took the stream from their webcam and fed this through I think FFmpeg or something that can turn this into ASCII, animated version of a video, right? And so he did that, replayed that, like played that stream inside terminal and recorded with Asciinema, and then he uploaded, and it was choppy. So because there was like thousands of small DOM elements being updated and then moved around every second. Well, if you have like even like 30 FPS source video material, that's just like lots going on all the
that's
time.
what you want to diff.
So that's
before you apply.
So that wasn't very performant. So I did some optimizations over the years. Tried to do some smart caching here and there, not recalculating some things, doing some more focused screen updates and stuff like that.
One would have thought that this is fairly easy to test, right? Because you've got a static input file and all you have to do is play it and check that the final view looks how you expect. Is it something like that?
Yeah, exactly.
Okay.
Yeah.
So when someone sends you a bug, the bug reporting must be pretty accurate.
Oh yeah. That's it is very simple.
Yeah, that's a big advantage.
Right. Yeah.
Okay.
Yeah. So just about the way it gets rendered. So another approach would be to, SVG is kind of would be very similar in performance to like just using some native HTML elements. And then there's Canvas or WebGL that could be used. So I play with the idea of using Canvas or WebGL for rendering the whole thing, but then I lose the native select and copy and paste support.
I think in this particular case, that would be a big loss, right?
Yeah, I would need to re-implement that. And while it wouldn't be like super hard, then it would be probably also not that good from like assistive technologies point of view.
Yeah.
So there's a lot of pros and cons for choosing like how you render stuff there. But recently I started like changing how I render background actually, because I can do background color. Typically it's just one color, but if you have Vim with some panels or some HTOP program running with all those green and blue highlights, this is the background color. So this stuff doesn't like take part in selection and copy pasting like the background color. So I can actually like render that on a separate layer below the text and make the whole rendering simpler and more efficient. So I'm playing with this stuff, just trying to find the right. And also at the same time, there are some solutions that I could have used and it would made things faster, simpler, cleaner. But not every browser supports everything, and I must point out that Safari is the new IE. It's just like, for me, it's been always like it works everywhere, and then in Safari there's always some glitch, some weird rendering problem. So that was like holding me back, because I want to support not just like Chrome and nothing else. But it gets better year after year. I'm patient, as you see, like
clearly.
And persistent. So I'll wait like a year or two, and some of those APIs or like improvements to rendering that I would love to use will be there, and then I will probably upgrade. So yeah.
Okay, so if I'm right, we've currently, in our point in history, we've currently got a Python recorder with a ClojureScript playback system on the web. Is that still the state of play?
No, that is not the state of play. That was 10 years ago. So, while we're on the player's side still, so I thought, okay, those high frame rate animations, I really want this to be smooth, and I want to be proud of how this player performs. What can I do that? How can I do that? And then I first started benchmarking and profiling how it performs the ClojureScript version. And what I discovered is that because ClojureScript uses immutable data structures, whenever you update an element of a list, of a vector, or of a map, you are effectively not updating it in place, but creating a new map and moving, referencing the existing elements. So basically, the container gets replaced. But this is a memory allocation, and so if you take animation in a terminal where the grid constantly updates, and the grid is made of vectors, is a vector of vectors, and each element of the internal vector is a map with a character and color attributes, etc. So if you want to just change one element in some place, you need to replace the inner vector with a new one that has this just like one element swapped, and then that forces you to replace the whole outer like a lines vector by taking the head and the tail and then inserting the current row between them. Which normally when you do this stuff in web apps, just shuffling some data structure, it doesn't really matter. But if this happens in an animation, it happens like tens of thousands of times per second. Then browser needs to allocate a lot of new data structures just for them to be garbage collected 1 millisecond later, because the new cell replaced the whole,
you create a lot of short-lived objects.
Exactly, a lot of short-lived objects, and so the pressure on garbage collector was huge there. So I realized back then that okay, ClojureScript is not the best language to have like a performant terminal emulator.
High frame rate animations, maybe not great for. But aren't you going to have the same problem if you go to JavaScript?
Well, not quite. Well, in JavaScript you can mutate things in place, so that's one thing. So one problem less, not that much pressure on memory allocator and garbage collection.
I would have thought there was still some, but
there is, yeah. And another reason why the player is no longer written in ClojureScript was the size of the library itself, because ClojureScript compiler produces huge bundles. That's because it includes a good chunk of Clojure's standard library, like core. What was the Clojure core? Well, anyway, so if someone wanted to use Asciinema Player on this side, they had to download this JS file that they downloaded from GitHub's release page. That was 0.5 megabyte in size. That was just like unacceptable for people. People were like, "What's going on?"
JavaScript cheats because people download the standard library with the browser, right?
That's true, yeah. But then also like I use various Clojure libraries in it, like core async and core match, I think, and a few others.
Okay,
and this adds up, and this really adds up. So it's I thought, okay, no, this is not like two reasons for like finding a better solution. And even though I really didn't have to, because as I said, like for the majority of use cases, it was fast enough. This other argument, just like the size argument, was like, okay, let's start thinking about alternative. And I thought, okay, there's WebAssembly now, which allows me to write very performant. To run run code very efficiently at near native speeds. I just need to compile something to WebAssembly, and then I will be able to embed that into the JS player. And so the idea was that the browser and some outer shell of the player would still be written in JavaScript, but the parsing of the stream and the virtual buffer maintenance and the whole terminal state maintenance would be written in something that will be blazing fast. So I chose Rust because it had very good story for compiling to WebAssembly. It was one of the early, probably the best language to use if you wanted to target WebAssembly, like 8-7 years ago. Now it's gotten better for many languages, but back then, Rust
it definitely seemed to lead the way on that one, didn't it?
Yeah. So I thought, okay, and I already been like interested in learning Rust, so I thought, okay, let's try. Let's see if I can re-implement that terminal emulator part that I had already in ClojureScript in Rust. So the domain was known to me. I just needed to write this in a different language. Try to be idiomatic as much as I could, but yeah, and it turned out very well. So I actually, one thing that really helped with like preserving the correctness of the parser and of the terminal emulation was that already in that ClojureScript version, the virtual terminal library, I had a comprehensive suite of property tests that were super valuable because I could assert on various invariants like the cursor position never goes, off the edge of the screen,
right?
Or that the number of lines in the vector that holds the current lines is never smaller or bigger than the number of rows that I maintain. For
there are
terminal.
a whole bunch of nice automatic constraints.
There's so many
domain, right?
of these invariants that must hold always. So I used some generator library that allowed me to generate those random sequences of text intermixed with control sequences, and was like asserting that everything is good. So that was very helpful, and I already had like a blueprint for that. So I did the same in the Rust version. So then I said, okay, this seems to be working. The ClojureScript version was player version 2.x, and the new one using Rust and WebAssembly was 3.0. So there was a new rendering part in a small amount of JavaScript and embedded virtual terminal inside of it.
I'm curious, what did you choose for the kind of JavaScript front of the front end?
I chose Solid.js.
Solid.js. I don't know much about that one.
Yeah, it's a React-inspired library, but very lean and focused on performance. And this one actually, I did a review of a bunch of options. Svelte was another option that I thought about. But I specifically looked for something that doesn't use virtual DOM, and neither Svelte or Solid.js they don't use a virtual DOM. So typically React and other similar libraries, they keep the virtual DOM representation in memory, and then on every update they rebuild the whole thing and then try to reconcile it with the actual DOM, which is not very efficient way. It's convenient and maybe conceptually easy for at least for the implementers of React-like library, but it's not very efficient.
Sounds to me like you've already got, because one of the advantages of React, of virtual DOMs, is you've got a logical model before you go to rendering, right? It sounds to me like you've already built your own logical model of what a terminal's current state is, so why have two?
Yeah, that's true. Yeah, to some degree, yeah. And so then I chose Solid because it seemed like small, and there was size was small, like the library was tiny, and it was very performant. I tested this, but it you use it almost just like React, so it's familiar. You can just write some. So the control bar, at the top of a player, there are some icons that you can enter full screen, etc. There's some bit of a UI or Chrome, if you will. So this is all those solid JS components, and then at the heart of it is also one component that basically maps this internal representation of the grid into DOM, into like a bunch of spans and classes, CSS classes.
Yeah. Were you then tempted to go back and revisit the Python recorder?
I did, yeah. I did. Well, there was a small detour actually in 2014 where I actually re-implemented the recorder in Go, and there are several reasons for that. But this experiment kind of failed. I wasn't very happy with it. Like, I really didn't enjoy either working with this code base in Go, and it didn't really I don't know. I just didn't fall in love in that in this phase of the CLI.
Okay.
Well, one of the priorities for me always was the ease of distribution of the recorder. So I tried to avoid too many external dependencies. So in fact, the Python recorder, the original version and the version that was still current just before last September, it was like zero external dependencies, only Python standard library. So it could be even it was available as a pip package on PyPy,
right?
But it could just be like a downloadable single Python file because it didn't depend on anything. And I really enjoyed that, but it was also like, okay, but it would be nice to have some more interactive things like terminal live streaming, but I would need to reach for some WebSocket libraries. Also, Python is not that, in my opinion, great language for doing like concurrency and network programming. It's a nice a starter thing for if you want to do a proof of concept. Very much.
I like Python a lot, but it's not what I'd reach for if I were doing concurrency. I'll definitely agree with that part.
Well, you can, but it's kind of pain and suffering. Yeah, it just depends on how much you can take.
There are other languages that kind of go with the grain a bit more on concurrency.
Yeah.
But
so
you weren't happy with Go. What took you away from Go? Because on the surface, good concurrency. It's got a great multi-platform deployment story, I believe.
I think at the time was so the practical things. Yes, like distributing single static binary was a win. But I remember there were constant problems with dealing with those low-level system things across different platforms, like on Linux and FreeBSD and Mac OS. And I think this tired me the most, probably. I thought that this will be abstracted away more than I thought. Maybe I was just used to how Python's PTY module and various other standard library modules abstracted a lot of quirks. And back then, this was not the case with Go. And I just felt that I just don't enjoy it anymore, and it's just a constant stream of frustration. And
when it's your own project, that is totally legitimate. Yeah,
and my I just also didn't enjoy the Go as a language. Like I learned other languages before and after that I feel are way more round or more cohesive and more I don't want to bitch here on Go. Just it's not my cup of tea. It turned out that just I don't want to spend my free time on my passion project with a language that I don't enjoy.
Doesn't spark joy, as they say.
Yeah, exactly. Yeah. So I thought, okay, I have still this is all working Python implementation, which I can still resurrect. I needed to backport a few new things that landed in Go version, but So then it continued as a Python code base, and then recently I had this idea that I would like to implement live terminal streaming. So not only you record, not only you would be able once again, you would not only be able to record a session and then upload a file and just rewatch it, but you will be able to share a link to a live session and let people watch it in real time. And so I started looking how to implement that. The server side, the Asciinema server, that would be a side in this live streaming is implemented in Elixir using Phoenix Web Framework, which is fantastic. Stack for interactive things for all the WebSocket-y things.
I've heard that.
Right. So so this part was already there and waiting for a client, for a command line client to connect and stream the session in real time. I just needed to find a way. What's the best way to do that? And I looked at how to do it in Python, but I wasn't really satisfied. And then one thing occurred to me that I need to solve one problem for live streaming, which is when someone joins, you send a link to a live stream to someone, and they join midstream, just later.
Yeah,
I need to. They need to see what's currently on the screen. Not only get new updates to the screen, but just what's currently there. So I need to preserve a state, and
I need a snapshot of what the window currently looks like. But you're not choosing to say, well, just every second I'll just send out a whole snapshot to everyone.
No. So the idea was that the CLI will connect to the Asciinema server, just send it to the endpoint there, and then the Asciinema server will fan out all those updates to connected viewers, which is how it is implemented right now. But so the server, being this hub there, could be maintaining this state. So when a new viewer joins, the server can send the state, which is fine. But then I wanted to make it more robust in a sense that what happens when there's this network disconnection between the producer, so the CLI, and the server. So I am doing streaming something in my terminal, like typing something in my shell, and then my internet connection goes for a moment, just for a moment. And how should I deal with that? Like, what should be the recovery path here? So my idea was that the client, the CLI, should be buffering everything, or do some other smart way of like preserving the last state. And when it reconnects, it pushes that state to the server, which can then use to just use as its own like state for the viewers.
Makes sense, yeah.
And so one thing that was really handy to have was this new Rust implementation of the terminal emulator I did for the player, which I was able to actually use in all three components. So it is used in the player for rendering, for like for playback. It is also used in the server, which uses it for generating snapshots, like periodical snapshots of live streams. So the like a poster image is updated in like every 5 seconds. If you look at a person's profile, and there's a section listing all this person's live streams that are currently ongoing. There's a thumbnail that gets like updated like every 5 seconds, and this is the snapshots taken by this Rust terminal emulator that lives in the Elixir server there.
Oh, hold on a second. How do you make that to work? How do you run a Rust program from within Elixir?
Yeah, there's a wonderful tool called Rustler, which allows you to integrate Rust code into Elixir or Erlang application. So Beam, which is a virtual machine for Elixir and Erlang, it has a concept of native implemented functions, NIFs, and historically this was mostly to support people writing like native extensions in C that they get compiled and then called from the Erlang code. So they do some heavy calculation and then quickly give you a small result. So Rustler is this library that allows you to take a Rust code and call it from Elixir. So this is how it's done.
Okay. Brilliant.
Yeah.
Okay, so you've got the Rust code running on the back end, and you're about to tell me that it's also got it running in the recorder.
Yes. That's the third final place where I have that the terminal emulator. So the reason for that is that twofold, actually. Well, threefold. There are many reasons, but the end result is that I rewrote the CLI from Python to Rust, because I could just embrace this terminal emulator library that I already had, and also Rust allowed me to go, not go crazy, but sanely approach all those concurrency problems that I have with live streaming and WebSocket connections running in the background, while in the foreground you are actually doing stuff in your terminal, and Asciinema recorder is not supposed to block you or print anything to your terminal, or just not interfere, but in the back somewhere there's various things going on in different threads, connections to the server, etc. So the CLI version 3.0 was released in September this year, and it embraces the terminal emulator library, which is called AVT, by the way.
AVT.
And it uses it for a few things. One thing, it really helps with maintaining state and help with those points in time where there's a reconnection to the server or stuff like that. Also, the CLI has actually two streaming modes. There is a remote mode and a local mode. So the remote mode is what we've been talking about. It connects to the Asciinema server that publishes it to the viewers on the internet somewhere. But there's a local mode where the CLI actually opens a local port and launches a web server, its own built-in web server with an embedded player. So you can actually share a link to your local machine for someone on the LAN on your own network, or if you're on some VPN, that should work as well. And then it will just go straight from the browser to your own CLI, to your own terminal, and be streamed directly without being forwarded by the proxy.
I have to ask you a question for my job here. If someone's is the client of a live stream, can they pause and scrub back and scrub forward and catch up? Because I could actually use the ability to broadcast my terminal around a room quite handily.
Right. So no, at the moment, no. The live stream is just live. There's no pause or rewind at the moment. Okay. There's a couple of challenges. This is probably one of the major topics I would like to tackle in the future. There were a few, I had a list of major things that the project was missing, and I've been checking off that list gradually, and this one is probably one of the few remaining points. So the challenge here is that because this is not a real video, and we can't really use existing solutions that were built for the video use case, for buffering and other things around that. I need to invent how I do buffering. I need to invent how I do rewind and how this works, because the naive way would be to just collect every event, session event that got delivered over WebSocket to the player in some memory array, and have it handy there. So if someone wants to rewind, stick back, I have it. I can just use that information. But that could potentially use a lot of memory. It really depends on how long is the stream, for how long someone is planning to stream. Some streams could run for forever, infinitely.
I've certainly heard of streams running for more than a day, being fairly common. Yeah.
Right. So right now, there's if you go to Asciinema.org, and there's a profile called Asciinema. On that profile, you can see that there's an ongoing live stream that streams the ASCII version of Star Wars Episode 4, and it's streaming for 2 weeks in a loop pretty much right now. I started it like 2 weeks ago, and I plan to just keep it like up and streaming forever. So that's an example of a case where just buffering everything doesn't work. So how much would we buffer? Like last 1 hour or something? But then in those terminal events are not uniform in size. They are not like, they don't have a constant bitrate because they really depend on how much was printed to a terminal. So like for any given like change that happened. So because Asciinema recorder doesn't really like take snapshots every 30 30 times a second, it just captures events that happen whenever they happen. And the print events can happen when the program decides to print something. So for example, if I leave my shell session like for 1 hour and like just like open while recording and go for a walk and I go back, then the actual file size of the recording will increase by 0 bytes because nothing happened between while I was away. Right?
Yeah, you've got some interesting time calculations there, because if the user were to scrub back by 35 minutes, the correct answer is absolutely nothing changed. But you've got a whole kind of stream of events plus stream of time model to resolve.
Oh yes, yeah, exactly. So then if I wanted to like buffer for live streams, buffer last hour, how much entries, how much bytes is 1 hour? Like this really is like a wrong question here.
So you need a variable buffer. Yeah, okay, I can see why it's not just something you can easily drop in. Right.
So then I could just like fixed size buffer for like and count the bytes, and so like 10 megabytes. I also want to be like considerate for the people who actually watch those recordings on various websites or on Asciinema.org or on different personal sites where people use the player, because this would take a lot of memory, and I don't want to use like few gigs of memory for just replaying text thing, right? So say I would use 10 megabytes for the buffer. So then what happens if someone wants to go back farther back than this, right? Where do I get this information? So there are many options. There are like, this is a topic for a whole separate conversation that can go on for hours.
I predict sometime in the future you're going to end up writing something that can store long sessions on S3 or something.
Yeah, that's actually one of the options. That's one of the options, just segmenting them and then keeping index of segments with like time ranges. This is similar. The idea is similar to like what HTTP live streaming does, HLS. This also like is there's some prior work in the video space that I could actually take some inspiration from. But you can see like that it's not the most straightforward thing to implement, because you need to. There are some trade-offs and questions and decisions made, and there's no like
I'm just wildly speculating here, but I wonder if a source of inspiration might be the security camera industry, because surely they've dealt with the problem of the camera image not changing at all for hours and people needing to scrub back to find the 5-minute window where someone broke it. Maybe someone at the Louvre would like to speak to you. Haven't they recently had those kinds of problems? Okay, I want to pull it back into user space a bit, because I'm keen to use this. So one thing I've found tricky as a user, and this is entirely my problem, but I'm hoping you might have some solutions, is I try and record a terminal session that I want to share with people, and I mistype something. And it's like you get 5 minutes in, you make a mistake, and you wish you could edit it. Is there any editing support for the sessions? Will there be? Can I snip out my mistakes?
So yes, there actually is, in the form of some community projects.
Okay.
So natively there's no real thing that I implemented for editing, other than just making the file format easy for people to just mess with, because actually the ASCII-cast format is a new line delimited JSON format, where every event is just like an 3-element array of like representing an event, where first element is a time, second is a type of event. Usually that's O, goes for output, which is printing, and the third is the payload, what should get printed. So you can just open that file in your editor and fix the typos there. It's not very helpful if you have like a lot of control sequences there, because they can really abstract what you're looking for. But you will find it there. Everything that got printed is in the file, and it's in plain text. So that's one way. Another is like there's a bunch of tools that people made. You can go to docs.asciinema.org, and in the about on the about page, there's a section called I think integrations. There's a bunch of it's not a complete list, but just like what I was able to gather of tools that can work with Asciinema, and some of them are actually useful for editing various aspects of. So there are tools that can replace some text, sensitive text, for example. That if you have some, you realize, I have some password there, like a AWS secret key, then it can find it that easily and replace it. There are tools that can modify timing, so like speed it up, or like remove long pauses, or various things. One thing that or you can do with the Asciinema CLI actually is concatenate multiple recordings. So if you can, for example, record in multiple takes a few parts of what you want to show into separate recordings, and then concatenate those files into a single recording, and it will just like make sure that timing is like properly, stacked on top of each other, and then everything is well.
Presumably you have to be really careful to make sure that the end state of the first file looks sufficiently similar to the start state of the next one, or it renders weirdly.
Not really, because it doesn't, like, the recording doesn't take the snapshot of a terminal window. It takes it records the events. So in fact, if you would be say you run command A, hit enter, and then get some output, and then type command B, enter, get some output, and then you have a recording file from that. If you did that in 2 steps, so like type A, enter, get output, exit the session, end the session, and then do the same for B and concatenate them, you will most likely end up with the almost exact the same file contents, except the timestamp of timing, of course, because that is very precise. But the reason is that it for that second recording, it only recorded what got printed since you started recording, not what was in your terminal before. So this is one tricky part that people can't wrap their head around, because for another example of that funny thing is that say you do some stuff in your terminal and your cursor is at the very bottom. You have a full terminal of just some stuff there. And then at the very bottom, you start recording. So what will get recorded is only the stuff that starts now. Everything above it is not visible to the new recorded session.
Okay, yeah, I can see that, but then that raises the question: when I start a new recording session, does it start with no prompt at the start?
Yeah, well, when you start a new recording session, like the initial state of the virtual terminal that will be used for interpreting those recorded events is blank. The cursor at the 00 and it's blank. But when you start a new session, Asciinema launches a new shell, like an embedded inner shell, which itself prints this initial prompt.
Yes, of course it does. Okay, yeah, I've missed that.
Yeah,
cool. So where before I leave you and go and record and try and edit some of my mistakes out in a new version, where do you want to take it next? Is the next priority like people being able to scrub back and forth across streams?
Well, I don't think this will be the next thing. Well, the thing is that this is still something that I do when I have free time. So it's not my full-time job. So what I typically do is like I work on something that's either useful for me because I thought, okay, now this would be useful for me right now. Maybe I'll work on that. Or I just feel like doing it because I think this will be so much fun. Or there's a major demand from the community, and I agree with that. Because there may be a major demand for something, and if I think, okay, this will be a pain in the ass to maintain for the next 10 years, I don't want to be doing that. So that's what happened a few times. But I try to bring features that are useful to people anyway. So I don't know. Probably the live advanced live mode with scrubbing. Not sure. Well, it's still somewhere in the plans, but I'm not sure when. Recently, I added actually this was a long-standing point on my to-do list, which was a full text search on Asciinema.org. So you basically can search for recordings that were uploaded by users by their full content. Everything that happens in a terminal is indexed.
Okay.
So you can try it out. So that was one cool thing that was a long time coming, but it's now there. I'm super happy about it. And just like now, probably the next thing when I will have time will be some improvements they already started playing with to the performance of the player and the whole like canvas background rendering. Just like I want this to be super efficient and performant. Just like it makes me happy when the software is performant, because we have super fast computers and I just like hate inefficiency. So this is my jam. So probably I will spend some time in the player area. I guess. Who knows? We'll see.
We'll see. Well,
yeah.
When you've got the all singing live stream multi-client server architecture running in a way I can play back and edit, we'll get you back into the podcast.
All right.
But for now, if someone wants to get started, it's asciinema.org, right?
Yes, asciinema.org. A good way to start is, of course, watch the introductory recording on the front page, but also go to the docs. There's a link in the in the header and follow the getting started guide, which is it pretty much is a great overview of all the pieces of the project. CLI, the player, the server. It shows you how you can do various things, and that you can also self-host your own server, how you can self-host the player on your website, and just like the getting started is probably a good jumpstart.
Awesome. I should go and record some demos that I've been meaning to publish for a while. On that note, Marcin, thank you very much for taking me through nearly a 15-year history. I'll join you for the celebration party.
Yes. And to the next 15.
Absolutely. Cheers.
Cheers. Thank you. Thanks for having me.
Pleasure. Thank you, Marcin. As usual, I'll put links to everything we discussed in the show notes. I think the place to start with a project like this, if you're interested, is sprucing up some of your old READMEs, because it's a great way to use it, and it's also a great way to show other people how to use your stuff. It really brings it to life. It can do, in a quick animated GIF, what it takes several paragraphs to explain. I'll leave you with one other link in the show notes. Marcin has put together a few fun demos of quite how far he can push this project. And one of them is a radio play called They're Made Out of Meat. And I'm not going to say any more about it because I don't want to spoil anything. But if you like sci-fi, it is definitely worth your next 5 minutes. Or maybe 5.5, because before you go and listen to that, please take a moment to like, rate, or share this episode with a friend or a social network. Helps people find us. And make sure you're subscribed, because we'll be back soon with another interesting voice from the software world. But until then, I've been your host, Chris Jenkins. This has been Developer Voices with Marcin Kulik. Thanks for listening.